Hello everybody, and today we're gonna talk about this thing. There's this thing over here, and so now I put this coil, put this coil thingy inside this thingy, and then what happens is it goes burr. It spins. Now I'm gonna show you how this works. Well, this was sort of this was a thing that we did in school, science class, and I'm gonna tell you what I think about how this works. So, firstly, there's this battery over here, and this is the plus part of the battery. So the current flows this way. If I put the coil in like that, then the current will flow this way. And also, there's this neodymium magnet, and if I see with this magnet over here, it pulls in and pushes S. So you can see that this part is the S part of the magnet, and so also there's this coil where the current flows through, and if the current flows this way, using the right hand, we can see that the thumb part of it is this way, this way. So the current, we learned this at schools, and from the coil, the the north pole side of the magnet becomes this way. I don't know if you can see my hand, but this way towards me. And also, so if you look at this coil, I don't know if it's working, but you can see it. But the current is flowing this way. So using the right hand again, the thumb part is the end side of the magnet. So if you look at coils, so if the current flows like this, this is the N part and this is the S part. And also, this there on this copper wire, there's a little bit of plastic coating on it to stop the current flowing through. But what we did in the science class was using sandpaper, we peeled off the plastic on this side. Then also, yes, and also to this side, we only peeled off the plastic on the top part of the coil. So, and then what happens if we do this is, as I showed you before, the coil spins. And I think how this works is, firstly, the current flows this way. So now, if I see it here, the coil flows flows like that. So using the right hand again, this is this side is S, and this side, the opposite side is N. And so, well, if it's right now like if it's in a state like that, I don't have to spin it, I think. Well, so this side is N and S, and then this side is N. So now, as I said, the plastic makes the current stop flowing, but we peeled off the plastic for a little bit of places. So this part of the coil is always connected to the thingy, the current thingy, and then this part is sometimes connected but sometimes not connected. Right now it is not connected, but if I flip it and make it connected, the current starts flowing and makes the magnetic field appear on this coil and makes this spin. But when the coil is connected to the flow, the current flows this way. By the way, the electrons flow the opposite way, but we say the current flows the opposite way of the electrons. But anyways, so now currently the current is not flowing because of the little plastic layer on top of the wire. But if I now turn it, now the current flows, and the coil is coiled this way, so like that, and the thumb part is the N part. So the N is attracted to the S pole of this neodymium magnet, so it spins. But then what happens is it spins, right? So the current stops moving because of the little plastic layer on top of the wire. So the current stops. So the current stops, but with inertia it keeps moving, and then comes to a state where it would like to where the N is over here and the S is over here again. So it wants to spin again. So with inertia and the electromagnetic force, it keeps moving. That's what I thought. And well, that's all I got to say talk in this video. So I hope you enjoyed this video, and bye.